Hello, class. And today we're going to pick up talking about Docker and container technology as a whole. So, what all we're going to talk about today is what is a container, obviously, how is it different from a VM, how do they work, how Docker run and other commands work, what Docker desktop is, and what container orchestration and containers in the cloud are. So, what exactly is Docker? Well, Docker or containers in general is a type of lightweight standalone technology that allow you to package up and create environments based on certain applications, code, or other dependencies. And they make it so that you have a shareable, consistent environment regardless of where you're working from. Now, they're also very lightweight and they use few resources in VM and they only run on top of your own system using the resources that you have. So it allows you to run multiple containers efficiently because of this. Now, Docker launched in 2013, and it's one of the technologies that actually, or the companies that popularized technology or container technology, and now holds a significant market share, about a third of all containers. And it helped to standardize container ecosystem a lot as well. But also, I shared a few examples here. You can see Singularity. This S here is one example, and that's for Research Cloud. And we also have the container runtime, which actually runs containers in Kubernetes and similar environments like that for orchestration. Now you can see when you use a virtual machine, we're pretty familiar with a VM, but what it requires is a full-fledged hypervisor, and this actually physically slices up the resources of the system so that with the hypervisor software running, you end up having separate guest operating systems, libraries, and applications all running separate devices on top of each other. And they're full-fledged systems with their own MAC address and everything. And you can only build them with the resources that you're able to provide from your own host system. And applications will run just as normal, and it would run just the same as a regular system would. But the downside is this takes up all your resources, and you're not able to actually share them. When you're using them, it's completely consumed by it, and it's a full-fledged system that's separate, which makes things difficult sometimes. But because of this, it's a lot more isolated. Now, where would I use a container versus a VM? Well, a container, they're often minimal and stripped down and focus on only specific libraries or just dependencies that are needed for an application. VMs have the full OS, which means that it would increase usage, but also provides a lot more flexibility and capabilities that the VM's able to run. Now, with startup and speed, containers are going to run a lot faster because they start almost instantly by only using the resources of your system, and they're very quick for scaling and for actually running and being consistent across environments. Now, VMs, on the other hand, take a lot longer to start up because it's a full OS booting up. And this makes them more stable, but it makes sharing them and running applications and creating this consistent environment a lot less precise. It takes a lot more time. Now, another flexibility is the use case of containers. They're really best suited for microservices and stateless applications, which means that they're able to contribute to where a container could be minimal and provide a certain service that you want to run in a certain environment, but perhaps you don't want to have to end up completely segmenting your device or installing a dual boot, which takes up a lot of storage. Now, the VM provides the full OS environment, which makes it better for certain applications as a whole to run, especially if there's requiring a complex setup of applications, but doesn't always make them better. Now, some of the benefits and detriments of containers is the benefits is obviously the efficiency and the speed. Since they're very lightweight and they share the resources, they're able to very quickly start up and they take a lot lower resource consumption compared to VMs because they only take what they need. And this makes them very efficient. And they're able to start up quickly and be deployed rapidly and scale a lot better overall versus VMs. And it's more ideal for microservices. Another benefit is portability and consistability. A lot of researchers try to use containers because they can create a consistent environment every single time you share it. And it's the same with people in the home lab and in the cloud development communities. You're able to make sure your services are always the same no matter what. And you just package up the environment that it needs and you put all the applications and libraries in there and it's good to go. Now, some of the detriments is there's limited isolation and security, and containers provide less isolation than a VM because it shares the OS kernel with the host. And this can lead to security risk, obviously. Now, this is also, there's some additional configurations and monitoring that I also need in order to maintain security and manage resource limitations in a multi-tenant environment. Now, how do containers work? Well, containers, like I said, are like VMs because they're a virtualized environment, but how they work is right on top of the host operating system. So you install Docker, and you can see here it runs on top of it, just like an application would. And each one of the apps runs as its own separate container, and this ends up building all on top of the host OS. And any package or any service you may need, this will be a single service or some multiple. And finally, you would end up adding up all the applications you have, and this would be required for the Docker container. Now, what is a Docker image? Well, this is the basic building blocks of Docker and how it actually works. You end up running Docker images, and this is how you build containers. And an image is used to share containers with others. It serves as a means by which to launch their architecture. And it's created when the container is created as well for a lot of times if you don't have it running. Now, you can look at these with the Docker images or Docker images ls command, and you'll see this more in the lab when we look at it, as well as Docker desktop a little bit more in depth since there's an extra credit section based on it. But I'll show everyone how it should look for you all. I'll also have a small little bonus on Portainer to show you what that looks like if you want to try running some of this locally as well. Now, this is what happens when you run Docker images or Docker image ls. You can see all the different images that we have on here. And you can see it's going to show the repository, it's going to show when they were created, it's going to show their size, what version of them by the tag, or any special things to note, and the image ID, which we can use to manage these. Now, what is a Docker file? I've mentioned this so far, but it's what you actually use to create your own containers because you can use a lot of pre-existing containers from Docker Hub, but sometimes you want to build your own. And you can build your own from existing containers as well. But there's three main sections to take in mind. First, you need the from section, which actually specifies the environment that it's from. Then you're going to do run commands, and this will actually do similar things to app install commands or other commands you're used to doing. And then finally, CMD or any commands that you have to run on the system itself. And you can see an example of a Docker file here. You can see from, we have Ubuntu 18.04, which is just what it sounds. It's a Ubuntu 18.04 operating system. And we have some run commands here. So you can see apt update is a run command we're doing. We're installing Apache because we're trying to run a web server. And you're going to do this later on in the lab and for the cloud lab to show you how running a web server actually works in the cloud. And you can see here we're running an echo command, which actually sets our index HTML for the web server, as well as echoing some base directories and some structure that we want, as well as permission for our file. And we also have this thing here that's the expose. Now, like you know with networking, you have to expose ports you want to work with. This is the same for applications. With Docker files and Docker containers, you have to expose whatever port it may need in the Docker file as well as when you run it. And then finally, we have a command here to run the Apache sh. So just making sure it runs everything. Now, Docker commands and running modes, there's simple start, which is with Docker run, and Docker will automatically download and start an image if it's not already locally available. You have detach mode or the -u with the run option, and this is to run it in the background, so it allows you to interact with other applications in your command line while it's running. And then you have flexible modes that support various different things. So one such one is the -it one, which is an interactive terminal that you interact directly with a container itself. And this is just some other common environmental variables that you have. So You also might assign it a name. There's the dash dash name option. You'll use a dash P to specify ports, and you can see this with the run example that we have here. You can set environmental variables, so this might be storage, other aspects. This was dash E, so you would also might specify a volume for storage. So you can create a persistent one or have a temporary one that's ephemeral, and you can end up setting this with a dash V option. And then you also have the dash dash device option for devices, as well as renaming user spaces and all that. And there's plenty of other ones with the dash user NS option. And feel free to look into this because this doesn't cost you anything. You don't have to worry about getting billed like you do with the cloud if you don't stay in the free tier. And these are some more managing commands for Docker. We have the Docker image RMI, which removes an image. This is something that we might do if we either have too many images, because some can be rather large, or if we just want to get rid of an old one. And you can actually remove a specific tag if you wanted to instead. You can do Docker image ls, which we remember that listed. We can do Docker container start, stop, or restart with the container name or the ID. I recommend the ID if you're having a hard time getting it to take with the name because sometimes it adds invisible spaces and other things that make it hard. But each one of these do exactly what stop sounds like: start it, stop it, or restart it. You also have Docker container ls, which shows you all your containers that are running. You have Docker container RM, which removes a container, and you want to use a container ID for that. You have Docker build-t with the name of the container and then a period. Now that period is not a mistake. That is something that specifies in Linux. It means here. You have to do that for Docker files. And the Docker ps-a, which shows the running services, which is that's why it's important to learn the different Linux commands because Docker is primarily Linux based with a lot of stuff it does. And this is an example of Docker Desktop, and you can see the getting started Docker link here. And that'll help you download it to your system so you can use the command line or the desktop if you want to run it locally. But I'll also go through how to use the install script so we can install that on our VM and then use the command line there. Now, when you run Docker Desktop, it is a way to visually orchestrate it so you don't have to use a command line, but the command line obviously gives you a lot of power by the flexibility that it gives you. But when you end up coming here, you're going to end up having 5 main tabs, 4 of which that you end up working with, and you probably only really work with the first 3 the most. You have containers, which is just what it sounds like. Containers are either running, stopped, or in a pause state. You have images, which are Docker images. You have volumes. So, like I said, you can create a volume or attach one. That's where this would be. You have builds, so different versions of Docker. And then you have Docker Scout, which helps you learn different things about your architecture, as well as some things are extensions you can add. And there's also a command line that has built in a few other features. As you can see here, this little graduation cap is where you can learn different things. And you could also use Docker Hub from here and search the images. Now, container orchestration is also something that's important. And you'll learn about this if you work more with the cloud. You'll hear the name Kubernetes a lot. This is an orchestration service. And this allows you to manage multiple containers at once through a main dashboard. And it allows you to automate a lot of it with scripting, where you might not be able to do so with Docker Desktop. Now, it's used for scalability, which, if you remember, that's one of the key things that we have in the cloud. We have 3 key services: that's network, compute, and storage. But we also have key aspects we want: scalability, reliability, efficiency, and automation of service in the cloud. And we want this with container management, whether it's local or if it's in public cloud. And another example is the Elastic Container Service, or ECS. That's Amazon's version of their container management service that they actually offer built into it. And while we don't use it in this course, it's something to be aware of if you go for the Solutions Architect Associate certification after the practitioner one. That's something that they have. And we'll talk a little bit about Portainer. I'll actually include a little bit about that with our walkthrough towards the end of the lab, can show you all how that will look and how you can actually work with that. And then finally, with Docker in the cloud, we have to think about, do we want portability and consistency across environments locally? Yes, we would also want this in the cloud too. And the cloud actually makes it more rapidly scalable and portable and efficient to use Docker a lot of times. And like before, it offers a lot of scalability because you can adjust to the needs that you use. And this makes your system a lot better because you can put this on, run your architecture in a container, and it will scale to meet the needs just as well as it would if you ran the application by itself. But it's going to be taking less overhead overall because it's only the containerized needed services. You also have the cost efficiency, like I mentioned, in the cloud, as well as the accessibility that you can access it from anywhere, even off of premises type deal, which is one of the draws to it. And you have the high availability and disaster recovery, which is something we'll go into later on. And how containers really work overall, just to summarize it up, is they allow consistency to run the same environment across all environments. They allow for speed, they're fast to start and rapidly develop. They're isolated, so they prevent app conflicts of issues on your system by doing so. And that can enhance the security, but it could also be challenging because of it. And efficiency, it uses fewer resources, so this makes it also more highly scalable overall. And that's just some more references if you wanted to check out some of these some more. But if this wasn't clear, we'll be going over this in the lab walkthrough. So just let me know if you have any questions.